Okay, let's get to it.
All right. So are we still living in a cowboy economy? In 1966, economist Kenneth Boulding referred to the cowboy economy as reckless and exploitive, similar to the way cowboys behaved in the Wild West during the 19th century, where they would settle somewhere, consume resources, and then move on. Boulding then goes to defend the spaceman economy against the cowboy economy. When up in space, astronauts can't throw away waste they generate, and moreover, every material is crucial for the crew's survival. So in other words, Boulding talks about a circular economy where resources are maintained within the system for as long as possible. So this phenomenon of a circular economy has been in our ancient history. For millennia, a robust reuse culture has existed within our society. Romans sorted trash in Pompeii, iron tools were refurbished from broken ceramics in the Persian Gulf, and in Athens, several buildings were built from a hodgepodge of recycled elements. But why did this change in our post-industrial times? Must all buildings die? For the longest time, buildings have often been assumed to have a life, but then what of their death? When buildings die, they not only create a macroeconomic climatic tragedy, but also an environmental catastrophe. So going back to the words of Kenneth Boulding, anyone who believes exponential growth can go on forever in a finite world is either a madman or an economist. So the building industry needs new models to reuse materials and accelerate towards this transition of the circular economy. So how do we give building materials a new life? How can we take forward these old age traditions of reuse, such as in this image of the triumphal arch of Constantine, which was built in 315, where elements were reused from buildings of previous emperors. These, how can we reuse materials like this today? We need data, 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 they say. Information is key to understand where materials are available, when they can be reused, and where they're located. So AKA, we need building surveys. We need an inventory of these materials to understand their potential for reuse. Now, traditional building audits are generally carried out before a building is demolished, but these are generally time-consuming and difficult to scale. And more importantly, these building elements are retrieved at the very last minute when a building is demolished, and it's not enough time for architects to be able to incorporate these reused elements in new designs. The McLeany curve shows us this influence of early decision design making on project outcomes. The greater the investment in information gathering in the early design phases, the fewer the expensive changes that would need to occur at the latest stages of the project lifecycle. So what data do we have? Well, in the city of Zurich, we have a digital strategy that recognizes open and accessible data, which is paramount for a digital economy. So we have the year of construction, the number of floors, or the volume of the building, which is made openly accessible, but we still don't really have information on materials in existing buildings. So then the question is, how can we data mine the city for this material information? Recent advances in Google Street View provide us 360 panoramic imagery of our streets and surroundings at a global scale. Google Street View imparts both spatial and temporal information that can help us understand which materials can be reused. Historically, the construction industry has ignored these kinds of data sets because they've been overwhelming to process and draw conclusions from, just because of the complexity of data analysis and management. But with recent advances in machine learning, we're now able to process these kinds of unstructured data sets. We can use machine learning for various types of material recognition. We can classify a building facade, identify whether it's a brick facade or not. We can identify windows using bounding boxes, or we could identify the pixel locations of different materials to then further calculate their existing material intensities. Our planet is a complex geolocated marketplace, and we need to rethink our circular design paradigms and challenge the way we look at the end of life of buildings. We need to shift from this exploitive ideology to a more restorative one. And now that we've talked about data quite a bit, I wanted to talk about this quote by Jay Breyer. We are surrounded by data, but we are starved of insights. So we have to actively engage with these massive data sets to extract knowledge from them to deploy circular strategies. And as an example, here you can see, once we detect whether it's a brick facade or not, we can then come up with early estimations of the material recovery pathways. We can understand whether we can directly reuse the materials, or if they need some kind of treatment or processing, or if it needs to be turned into a secondary utility using recycling. So then the question is, can we create a resource map of the city using this information? This temporal and spatial data can help facilitate local reuse practices and could also act as a design agency to critically assess material lifespans. And this sort of early identification can help bring about an extended time period between the end of life of one building and the start of another. So this time buffer allows for the matching of components that are available for sale, and it also reduces the amount of storage time that these materials would require. Now, wouldn't it be great if we had this data in real time, though? So this idea of digital twins, where we have the real-time digital counterpart of buildings, has been gaining momentum in the last few years. And such real-time data could also help us monitor our buildings better for repair and maintenance. And now I'd like to end by just saying that data has been compared to oil and gold, and such is its value to the global economy. But now they say data is like water. It needs to be accessible and clean. So my question to you is, how do you think data pipelines can be used to achieve a spaceship economy?